At some point last year, I sat down and asked myself a question I've been avoiding for a while. I used logging libraries, I've set up tracing pipelines, I've wired up metrics dashboard, but if someone asked me to explain from first principle how any of it actually works, I wouldn't be able to. And I am a senior software engineer who has built backend systems processing over 1 million transactions a day. That bothered me enough that I decided to fix it. So I built Corelens, a developer-first observability SDK for Node.js from scratch. Not because existing tools are bad, but because building it was the only way I was going to actually understand what I was working with. This video is about everything that I learned while building Corelens. By the end of this video, you're going to understand what observability actually is, why the three pillars, logs, metrics, and traces exist as separate things, and what it takes to build the infrastructure that powers them. Even if you don't end up installing Corelens, you'll see your existing tools entirely different. Let's start with the word itself, because it gets thrown around constantly and almost no one defines it cleanly. Observability in the systems engineering sense is your ability to understand the internal state of your system from the outside. Not just is it up or down, but what is it doing? Why is it doing it? And where is something going wrong? The reason this matters is simple. You can't step into a running production system and look around. You can only see what the system tells you. So if your system doesn't speak clearly, you're flying blind. The three main signals your system can emit are logs, metrics, traces. And here is what most engineers don't realize. They are not just different formats for the same thing. They answer fundamentally different questions. Logs answer what happened. Metrics answer how much, how often, and for how long. Traces answer what paths did this request take through my system. If you're only using one of them, you're building with one eye closed. When I started thinking seriously about observability, I did what most engineers do. I looked at what was already out there, Pinot for logging, Prometheus client for metrics, OpenTelemetry for tracing. All of these are actually solid tools. I still use some of them today. But here's the thing. When I tried to understand how they worked, not just how to configure them, but how they actually move data from my application to a backend, I kept hitting this invisible wall. Documentations that assumed I had prior knowledge, abstractions stacked on abstractions. Telemetry is powerful, but it's also a spec built for every language, every platform, and every backend. That generality comes at a cost. It is not easy to reason about what's happening inside it. I didn't just want to use the abstraction. I wanted to understand the layer underneath. So I started building. Here is what I didn't expect though. Once I started building from scratch, the concepts that had always felt vague became completely concrete. Let me give you one example. Structured logging sounds simple. You add some JSON fields to your log lines and that's it. But once I started building the log pipelines, I had to answer questions I've never asked before. What happens when the logs are produced faster than they are exported? Do you block? Do you drop? Or do you buffer? These aren't hypothetical problems at all. In a high traffic system, your logging pipeline can actually become a bottleneck that slows down your application, or a silent data loss point that drops events without telling you. To handle this correctly, I had to build a bounded queue, add back pressure handling, and batch processing into the pipeline. None of that was visible when I was just calling logger.info. Same thing with tracing. Distributed tracing always felt magical to me. You click a trace in Jaeger or Datadog and it shows you the full path of a request across multiple services. How does that even work? The answer is context propagation. Every request carries a small header, a trace ID, and a span ID that follows it through every service that it touches. Each service reads that header, records its own span, and passes the context along. That's it. It's not magic. It's structured header passing along a collector that stitches the pieces together. But I only understood that completely when I had to implement it. I had to write the code that reads W3C trace parent headers, creates child spans, and propagate context through async call stack using async local storage. That's when it clicked. Most engineers stop there. The ones who don't are the ones who build things that last. So what is Corelens actually? It's an observability SDK for Node.js that includes structured logging, metrics collection, distributed tracing, OTLP export, HTTP instrumentation, runtime metrics collection, configurable sampling rates, batching, retry handling logic, circuit breakers, and graceful shutdown, all built from first principle. It currently supports Express, Fastify, Hono, and Nest.js. But here is what Corelens is not. It is not a replacement for OpenTelemetry. It is not trying to compete with Datadog or Grafana. It is a learning instrument that became a production tool. And the reason why I'm building it is to make telemetry data collection as enjoyable as writing code. I love it if you enjoyed using Corelens. I think the best way to understand observability is to understand how the pieces are built. And this channel is where I'm going to teach all of that. If you're building Node.js systems and you felt the gap between I set up login and I actually understand what's happening in my system, this video and the next is for you. Over the next several videos, I'm going to cover how logs, metrics, and traces actually work under the hood, real implementations, real trade-offs, real architectural decisions. If you're working on a system right now and you want to go deeper, or you just want to follow the build, subscribe and start the next video in this series. Everything I build here is open source. Links are in the description. So, observability is your system's ability to tell you what it is doing. It does that through three signals: logs for events, metrics for measurements, traces for request flows. Most engineers use these tools without understanding them. I was one of them. Building Corelens from scratch has forced me to understand every layer in the stack, like the queues, the context propagations, the export pipelines, and reliability patterns. This series is about everything I learned building Corelens from scratch. The tools you use every day are more interesting than you think. And once you understand them, you will use them in a much better sense. I'll see you in the next one.